The ANSI SQL standard on the create table statement is summarized on this slide. Note about the primary key clause in the standard. It is useful for defining a composite primary key. If the primary key is singular, the reserved words, primary key in the key field clause is simpler. Note also the NO action option in the referential integrity constraints. It is not recommended because we would have no control over the data integrity of the database and outcomes of database changes. The practical use of this action is limited to doing massive database migration from one database to another. In such scenario, it allows us to turn off the referential integrity constraints temporarily for the data migration. After the project is completed, the database administrator should restore the referential integrity constraints as designed before deploying the database to production. Note that the support to the ANSI SQL standard varies from database vendors. You should always refer to database administration manuals to understand the support in a selected database system. For example, the Oracle database system does not support the onUpdate action, while the Microsoft SQL Server supports both onDelete and onUpdate actions. It is very important that our database design must be complete, and not restricted by what database system to be used to create the database schema. If we create the relations in an Oracle database, we can simply comment out all onUpdate actions in the SQL statements. When we need to switch to a different database system like Microsoft SQL Server, we need only remove the comments in the SQL statements without having to make database design changes. Interact with ChatGPT to understand FK referential constraints. Example prompts. I am studying the foreign key referential constraints in my college database class. Could you explain the concepts and show me some examples? After reading the response, you should ask for explanations and examples of new concepts mentioned in ChatGPT's response. The order to create relations matters. Because of the foreign key references, all primary key relations must be created before creating foreign key relations. Otherwise, the database would raise an error on not being able to find the referenced primary keys. Let's use the university database as an example. We can use the logical ER model to help us decide the order to create the relations. Create relations that have no foreign key. In this example, this group includes student, college, and course. Create relations those foreign keys reference only those relations already created. The second group would include student phone, advisor, and department. Repeat the second step above to decide the next group of relations, which includes advisor phone, advisory, instructor, and program. Repeat the second step above to determine the fourth group of relations, which includes person phone, student program, program course, and class. Repeat the second step above one last time to determine the last group of relations, which has only a single relation enrollment. With that, we complete all tasks involved in creating a database schema. The ANSI SQL standard included complete languages for data definition and data manipulation. The SQL Data Definition Language, DDL for short, contains all commands for creating database schemas, i.e., relations, fields, referential integrity constraints, and others. It also includes commands to alter the relation fields and drop relations. The alter command can be used to change the definition of a relation, including adding a new field, deleting an existing field, renaming a field, changing the data type, changing the foreign key references, and many more. The SQL Data Manipulation Language, DML for short, defines commands to modify data in a database. It includes commands to insert data into a relation, update values in a relation, delete records from a relation, and other data manipulations. We cover only a subset of those commands in this class due to the time limit. You can search the internet and interact with ChatGPT to learn other commands, their syntax, and examples. Here is the syntax for the SQL insert statement. Note that the field names may be omitted under two conditions. First, the sequence of values matches the order of fields in the create table statement. And second, the SQL statement provided values for all fields. If we don't remember the order of fields in the create table statement, or some fields have no data values in a SQL insert statement, we must list the field names to match the values. Otherwise, data could be inserted into the wrong fields. Here are examples of SQL insert statements. The first example listed all fields to match the values provided in the SQL statement. The order of the data values only needs to match the order of fields listed in the statement. The second example omitted the field list and used the order of fields in the SQL create table statement for student. In this example, the credit hours field is the last field in the create table statement, compared with the first example above. Use the identity field type to create AutoNumber primary key. The values of a primary key may be a set of numeric numbers with no application-specific meaning. Examples of such primary keys include the Panther ID of GSU students and the CRN numbers of classes. Such primary keys require only unique key values. The Oracle database supports the identity field type to generate unique numerical numbers automatically. The GSU student relation example showed that the primary key field, Panther ID, is an identity field of as 9 digits numbers starting from 1000, increment by 1, and sequential. After the relation is created, the database will always generate a unique 9-digit number for each new student record. Thus, the AutoNumber field should not be listed the SQL insert statement as shown in the example. It is because there is no need to request a unique Panther ID for this new record for the AutoNumber key field. The Oracle provided the sequence object for AutoNumber fields. The sequence object can also generate AutoNumbers. This example showed how to define a sequence object for the surrogate key, phone ID, in the student phone relation. Like the identity keyword, the sequence object can be used for primary keys, but the sequence object can also be used for any AutoNumber field and can be shared by multiple fields, which is very handy to use. Because sequence objects are not part of any relation, we must explicitly request the sequence object to generate a unique number each time we need an AutoNumber, like this example of inserting a new student phone record. Other differences from the identity field are that every sequence object must have a unique name, while an identify field has no such a requirement. The sequence object must be manually dropped using the drop sequence command explicitly, while an identify field is part of a relation and is deleted automatically when that relation is deleted.